Right, let's start. Okay, this is session 5, Math 120. Sure, it's recording. Yeah. Check. Yeah. Okay. All right. Oh, all right. It doesn't like to be minimized. All right, session 5 today, 7th of February 2018, Math 120. You guys doing okay? Yeah. All right, let's have a prayer. Father God, we thank you for today, for tonight, another class that we can learn about the mathematical pattern that in which and by which through the Lord Jesus Christ we have created the whole universe, and by learning it we can get a little bit better and more glimpse of your knowledge and your beauty. I ask your blessing upon our class, upon all the students both in class and online, both for this course and if they are taking any other class. May you bless them and strengthen them, and what we learn here at the seminary may be used practically in ministry for your glory. For in Jesus' mighty name we pray. Amen. Any question before we start? Oh, sorry. I will put the grades in tonight. Yeah. You guys are doing fine, so don't worry.
I'm very, I like instant gratification.
Oh, okay. You're doing fine. You're doing fine.
Test, I'm like,
Yeah, don't worry. Don't worry.
No,
I mean, I didn't do it in 30 minutes. It took me the whole 2 hours.
Okay, that's fine. That's fine. All right, we will start with this session. Very quick and short view of algebra. Algebra is basically generalized form of arithmetic, which uses letters of the alphabet called variable. So whenever we have, we want to represent different numbers, we use letters of alphabet, X, Y, A, B, C, and we call them variable. If we have some kind of representation for a specific number, specific quantity, then it's called constant. And I'm following the PowerPoint for the online students. Then, when we put all these things together, variable, constants, numbers, parentheses, operation symbols, we get algebraic expression. When two algebraic expression joined by an equal sign, then we say this is an equation. They're equal. And we can find a solution to an equation. When we do that, we have solved the equation. One of the common things in algebra is to evaluate different algebraic expression, means to find the value of the expression for the variable which are in that equation, which make that equation true. Let's look at some of the examples from our textbook. Examples 1 through 3, page 309. Always my own marker. All right, you guys tell me. You have this. This is an algebraic equation. Constant, 7, constant 1. Constant is a variable, constant. We want to evaluate this algebraic equation for x equal to 6. So what do I do? Minus, you guys tell me what should I do? 7 plus 5 parentheses. Then instead of x, I put down 6 minus 4 over 2. Okay. this would be 7 plus 5 times 6 minus 4, 2, power of 3. Okay, 7 plus 5 times 2 to the power of 3 is what? 8.
And 8 becomes 2.
Okay, so we get 7 plus 40 equals 47. Right? You go. We have this algebraic expression for equation. Algebraic expression. And this is a variable. These are the constants. Tell us to solve it for x equal to -6. So first thing, just replace value of x in this expression. So you have -6 to the power of 2 plus 5 times -6 and -3. All right, what is -6 to the power of 2?
6 times 6, so 36 bucks.
Yes. What is 5 times -6? I need a zero. And -3. So this would be 3. Whatever. All right. How about this one? A little bit different. We have variable x and we have variable y. Okay. So it tells us to solve this expression for x equal to 4 and y equal to -2. So we have -2 times 4 to the power 2, 5 x is 4, y is -2, and then minus 2 to the power 3. Okay. -2 times, what is 4 to the power 2? What would be, here we have 5 times 4. What is 5 times 4? 20 times 2. 40. What should be the sign? Because this is negative. And how about here? We have minus 2 to the power of 3. What would be? First, tell me the sign. Negative. And 2 to the power of 3. Okay. And we have -2 times 16 is plus or minus -32 -40 minus times -8. Okay. This would be actually become -64. Yeah. Because comes 32. Okay. Any question?
The next one. But they brought it down as -72.
So yeah,
So yeah, that all works out the same.
the doesn't matter that you first add these two or subtract these two. Now, some of the vocabulary. The terms of algebraic expression are those parts that are separated by addition. For example, even here, this is one term, another term, another addition or subtraction. Actually, well, this would be one term, this whole thing would be another term.
So it's only one separate by addition.
Yeah. It can be minus separate. Look, for example, let me. Let's look at this one here on your PowerPoint. Right? You have 7x minus 9y minus 3. Well, I can write that. I can write that, but if I want to put parentheses, it would be 7x plus minus 9y plus minus 3. Yes? Then my terms are, these are my terms. One term. Another one. All right. Now, here, two different things you need to know. Coefficient and constant. These numbers next to variable, like 7x, 9y, these are called coefficients. 7, 9. Or you can say this is plus 7, this is minus 9. These are coefficients. They go next to the variable. These that are representing a specific number, they call constant. Minus 3. Okay.
Would it be safe to say the number next to
The number next to a variable is a coefficient. A specific number, which is not next to any kind of variable, constant is a constant, because minus 3 is minus 3. But this can change depending on the value of x. Right? You know, if it's just a number, a numerical number, then it's a constant. You can actually look at it, you know, the reason I kept the sign, because then you can, putting it back, you get the expression. But you can more simplify it. If you want to just look at it as an absolute value, just 7, 9, and 3. But then you have to keep in mind the signs. So I prefer the signs. Now, when we have two parts that are multiplied by together, they are called factors. The factor of, for example, what we have here, let me use another color. 7 and x. Okay. Then like terms are terms that have the same variable. 3x, 7x. You can add like well, if you have 7x or 3x, you can add them, you can subtract them. If you add them, you get 10x. Yes? Yes. Now let me ask you a question. How about here? Are these similar terms?
If they are, if they represent x of y.
Yeah, but I mean, when it's x.
No, because it's
Yeah.
X.
Yeah. They are not like terms. They have to have the same exponent. Again, the distributive property of the real number enables us to combine them. Like, the question that I was thinking to ask here, this is because of law of distributive property of real number. You can, what you can first get the total of minus 40, then add it to the 8, or you can do this one. 40 minus 4, and minus 40 plus. All right. So if we look at table 312 in your textbook, please look at the table 312 for the online student. You can see all those tree properties, commutative properties, associative properties, distributive properties. You use them for an algebraic expression. Like, let's look at one of them. A plus B is equal to B plus A. A times B is equal to B times A. A plus B parenthesis plus C is same as A plus parenthesis B plus C. But this is very useful in algebraic expression, the distributive property. A times B plus C. B plus C. Distributive property. The value of A is distributed between these two. It's equal to AB plus AC. Yes? Or this is equal to DA, I can reverse their place, plus CA. Yes? They're multiplied. I cannot connect these two, but I can. So A times B is the same as B times A. 2 times 3 is the same as 3 times 2. A times C is the same as C times A. Is that clear? We simplify an algebraic expression when parentheses have been removed and like terms have been combined together. let's, for example, look at exercise set 6.1, pages 314. All right. Page 314. 315. Okay. That's on page 315. Let's number 41. It says 7x plus 10x. 7x plus 10x. All right, you guys tell me. 7.
Can you just go ahead and do simple math on this and do 17?
Yep. Because these are like terms. Say variable, say exponent, so it becomes 17x. Simplify it. And if the question give you a value for x, then you can plug it in and find, the real number. Like if x was 2, for example, then this would become 34. All right. Let's look at number 62. 7x minus 10. 7x minus 4 and is here 6 minus 8 minus 5x. Okay. Oh, where shall we start? Start with this. Okay? Oh, just forget everything else. Just think that you have, that's all we have. So 6 minus, you multiply this is like minus 1, yes? Minus times 8. You follow me? What I have here is just like if I put a 1 here, it doesn't make any difference. Okay. So I have minus 1 times plus 8 is minus 8. Yes? Minus 1 times minus 5x is what? Okay? Okay. Don't worry about what's outside. So you have 6 minus 8 is what?
Minus 8 is negative 2.
Yep. Plus 5 is. Okay. That's it. That's all we can do. It's like inside.
No, it's because they don't have the same length.
No. So that this is constant, it's a variable. Now you have this off for there. So you have 7x. Then you have to multiply this with minus 4 here. Minus 4 times minus 2. Minus 4 times plus 5x.
Plus 1. Negative 1.
No, oh, times.
Oh, times 20.
Negative 20 and x. And this are so this is what we get. What can I do here? I have 7x and minus 20x. So, okay, what would be x? We have positive 7 minus 20. What's the sum? Minus 13x plus 8. Or I can write it doesn't matter. 8 minus 13x. Okay. Let's go. Now we come to linear equation. A linear equation in one variable is an equation that can be written in the form of ax plus b equal to 0, where a and b are real number and a is not 0, because if a was 0, then you don't have a linear equation. X would be 0 and b be equal to 0, b has to be 0. Following me? Yeah, okay. Now, the addition and multiplication properties of equalities, we can use that. Let's see page 318. There's a table there, but actually I want to do an example. Okay, I want to do example 3, page 319, example 1. We have this algebraic equation. We have 2x plus 3 equal to 17. 2x plus 3 equal to 17. Whenever you have this kind of algebraic equation, you are asked, you're looking for to find the value of x, which makes this equality true. Okay, so what do we do? Yeah, minus 3 here, minus 3. These two cancels. You get 2x equal what? 14. Then divide both sides by 2. Equal to 7. And to check it, if you plug this back over here, 2 times x times 2 times 7 is 14 plus 3. All right. Yeah, I love algebra. It's once you learn some of the basic principle, it's very easy. In fact, when I was a math major, one of the reasons I chose to be a math major was, I don't know if I ever told you, was it, provided I understood the principles, there was very little I had to do. Very little work. Okay, solving linear equation, you simplify algebraic expression on each side by removing grouping symbols and combining like terms, collect all variable terms on one side, all the constant, or like what we did here on the other side, isolate the variable and solve it, and then check the solution in the original equation. Exercise 6.2, page 328. Some of these. let's do, for example, number 14. 3x plus 8 equal to 50. Yeah. 3x plus 8 equal to 50. Okay, and just like that. We want to find the value of x, and if you plug it there, this equality holds. So what do? We subtract minus 8 from both sides. Cancels. Yeah. Equal to 2. Divide both sides by 3. So 42 divided by 3 should 14. And if you put 14 back in here, 3 times 14 is 42 plus 8. Right. Let's do number 31. Eight like minus 3. 11 equal to 11 y plus 9. All right. So you want to put all, you see here, these are our variable. These are our variable. These are the coefficient. We want to have all of them in one side and this constant on another side. Usually you put the constant on this side of the equality side. So first, I add plus 3. Okay. These two cancel. So I get 8y is equal to 11y plus what?
6.
No.
Plus is going to be 11.
3 plus 9. 12.
Yeah, you just said 12.
Okay. Now, I want to have y's on one side. So I subtract minus 1. No, I'm sorry.
Minus 11.
So these cancel. I get plus 12 over there. What do I have over here? What's this one? Minus 3. Okay. And what do I do next? I divide both sides by what? Negative 3. 9 is equal to minus 4. Okay. To check it, just put that back for the y over here. 8 times minus 4 is minus 32. Minus 3 becomes minus 35. 11 times minus 4 is minus 44. Plus 9 is 35. Both sides forward. Okay. Any question? No? Okay. Cross products principle for proportions. If you have, again, please look at your PowerPoint. If you have A over B equal to C over D, you can cross product. You can have it. A over B, that's true. C over D, you do cross product, meaning this multiplied by that equal this by A times B is equal to B times C. Right? Let's look at example 7, page 325. Uh, 63 over x. Okay. 63 over x equal to 7 over 5. And we want to solve this for value of x. So what do? This times that, x times 7 is equal to 63 times 5, which is 315. Okay? All, and divided by 7, both sides cancel. So x is equal to 45. Right? Okay. Let's do the number d. Uh, 20 over x minus 10 equal 30 over x. Okay, you guys tell me what to do. Okay, so this time that
20x is on the right hand side.
x.
And it's going to be 30x minus 10, which is 20.
No, multiply.
I'll multiply 9.
Then, okay, or actually, add 30x to both sides. Add 30 to both sides. At 300, I'm sorry. And if you can, at the same time, you can minus 20x for both sides. Following me? Right? So these two cancel, and these cancel. 30 minus 20, x equal to 300 divided by 10. You get x is equal to 30. Okay. Right? I'm not sure. Let me check. page 329. Maybe let's do number 70. We have 2 over y minus 5 equal to 3 over y plus 6. Okay. Now, you guys tell me how would you write it? 2 times y minus 5. Yes? Oh, I'm sorry. No. This should be 3. 1, and then 2 times y plus 6. Okay? Then you multiply this 3y minus 15 is equal to 2y plus 12. Okay? And we subtract. Let's see. I subtract minus 15 on both sides. And I subtract minus 2y on both sides. No, I'm sorry. I add plus 15. Yeah, I add plus 15 to both sides. So minus 15 and plus 15 cancels. 12 plus 15 is 27 plus. And these two cancel. 3y minus 2y is y. So y is 27. Okay. Let's go. Algebraic translation of English phrases. Let's look at that, page 322. Oh, no, I'm sorry. Not three. Okay. You know, like, if you look at your textbook on page 332, for example, it says the sum of a number and 7. That's it. In English, you're translating it into mathematical language. Sum of a number. What should I write?
Which way are you looking at?
And that table, top of the table, the sum of a number and 7. Just without looking at the answer. Can you tell me? So
it's whatever letter you choose, like X or Y.
X.
And then your sum is plus.
So whatever, not sum of a number, whatever. Okay. Let's look at in the middle multiplication. Then in the middle of that, 75% of a number use decimal. So how would you remember 75% if I want to write in a decimal form? How would you write? 75%.
Oh, 0.75.
0.75. 0.75 of a number. 1. Then let's look at that. In the last row in the middle, 25% of sum of the sum times the number and 14. So let's start. First, you're talking about the 25%. How would you write that in the mathematics?
It's going to be 0.25.
Yes. Then you have 25% of the sum. So we know whatever it is, you have plus. sum of 3 times a number, whatever that number. So 3 times a number, how do I write? X. And what? And 14. Just- Okay. So this is how you translate, and you need that. That's where algebra is used to model real life problems. Step to solving board problems. Read the problem carefully, at least twice, to be sure that you understand it. If possible, draw a sketch to visualize the problem. Then determine which quantity you're being asked to find out. Find out what are you looking for? What quantity is being asked to find out. Choose a letter to represent this unknown quantity, usually X. Then write down exactly what this letter represents to remember for yourself. Write down the problem as the equation, solve the equation for that unknown quantity, answer the question or questions asked, check your solution. Let's look at some of these. Example 1, page 330. On example 1, page 333, gives a graph of average yearly earning in the United States by the highest educational attainment for male and female. It says the average yearly salary of a man with an associate degree exceeds that of a man with some college by 3,000. The average yearly salary of a man with a bachelor degree or more exceeds that of a man with some college by 41,000. Combined, 3 men with each of these educational attainment earn 188,000. Find the average yearly salary of a man with each of these level of education. And all these numbers you get based on that table on page 333. So first, you have to read that quite a number of times to really understand what you're looking for. You want to find the average yearly salary of men with each of these different levels of education. So it says, let X represent one of the unknown quantities. We say, let's say we know something about the salary of men with associate degree and bachelor degrees or more. They exceed the salary of the man with some college degree by 3,000 and 41,000. So let X be the average yearly salary of a man with some college. So you choose the lowest, okay? You choose the lowest for the unknown X. Then represent the other unknown quantities in the term of X. The problem told us that the man with some college degree, with some college education, earned $3,000 more. So the average yearly salary of men with the associate degree, the one with the associate degree earns $3,000 more than somebody who just did some courses. Okay, are you guys following? All right. So it would be X plus 3. The one with the bachelor earns $40,000 more, so it will be X plus 41. Then it says if you add these 3 together, the average of these 3, the income, the total income is 188,000. So you get X plus 3 plus X plus 41. And to solve that problem, you get 48,000. So 48,000 is the average yearly salary of a man some college. You can this way find it. First, a man with associate degree and a man with a bachelor. So if you put them back, add them together, you get 188,000. You guys follow? All right. Example 4. Yeah, let's look at example 4. Your local computer store is having a turkey sale on a digital camera. It said after 40% price reduction, you purchase a digital camera for $276. What was the camera price before the reduction? Let's do that actually here. All right. So it said, what are we trying to find out? The original price before the discount or sale. So we call it what the thing that we are trying to find out, we call it X. Okay? Then it's giving us the sale has 40% off of the original. When you take off, so I need to have subtraction. Yes? 40%, how do I write that in decimal? What? 0.40. Then this is how much discount. When we subtract that, what's the value? 276. This is given to us. Okay? So when you solve this problem for x, actually x minus 0.4 would be 1 point up to 0.6. X is 276. We multiply both sides by 100, and that's easier. I prefer, I prefer to multiply them by 100, so I get this decimal. So I get 6x equal to 276. 27,600. Then divided by both sides by 6. X is equal to 460. Right. Follow. Any question? Huh?
Why would it not just be as easy if you know that your regular price what you're paying?
Yeah. So 276 after discount, you pay 276. You know the discount is 40% of whatever the original price.
So your assumption is you don't prices.
It's not like you go to a store and it has a tag and
exactly.
you go there at the cashier, it tells you how much. No, that's situation is that you don't know what is the original price. The original price would be 460. But if you look at it just quick and fast in your mind, which is 40% is almost half. Almost half. So it tells me 270, that rounding estimation that we taught, I think it was session 2, but it tells me, yeah, if I get almost half of 276, actually, I get the original price. Right? Okay. Any question? Nathan, are you okay?
No, I'm just making myself.
Linear inequalities in one variable. Now we have inequalities instead of equation, and we want to solve them. to find out whether that statement is true or not. These numbers are called solutions of the inequalities, and we say they satisfy that inequality. The set of all solution is called solution set of the inequality. Then we can graph linear inequality in one variable. Let's, for example, table 6.3, page 4. Here, if we go to page 342, if you look at your page 342 and 343, for example, it says, again, remember when we had that discussion about set, x, we have those brackets for x, then a bar, all x less than a. So on a line, you have a and b, all x less than a, but notice the point A is an empty circle because it's not equal. If it was less than and equal, it's a solid one. All x greater than b, all x greater than equal to b. X between a and b, but not equal to them. You see it down there. All right? Let's look at, for example, example 1. Talks about number 8, for example. It says x for all x less than 3. Graph the subsets of real numbers. If I want to do that on the number line, here's 0, 1, 1, 2, and 3, minus 1, minus 2, minus 3. If you notice, this is all the number less than 3. So this should be an empty circle all the way down to minus. If we have x greater than or equal to minus 1, it would be this is 0, this is minus 1, minus 2, 1, 2, 3, greater than equal to minus 1. So first of all, because of this equality, this should be solved, yes? Then, which way do I go? That way or that way? Up to the right. Now, if it says x, if you have an x which is between greater than minus 1, but less than or equal to 3, then it's greater than minus 1, but not equal. So this should become an empty. So goes that less than or equal to minus 3. Stops right. Following? All right. Solving linear inequalities in one variable, the procedure for solving linear inequality is the same as the procedure for solving linear equation, with one important exception. When you multiply or divide both sides of the inequality by a negative number, you have to reverse the direction of the inequality. Okay, let's look at some of these. Example 2, page 344. All right. Four x minus 7 greater than or equal to 5. This is called an inequality because of this sign. It's not an equality, sorry, it's not equal, okay? We want to solve that. What do we do? That one. All you have to do is just first change that. Assume this is like an equal sign in your mind, all right? So you have 4x minus 7 equal to 5. You solve it for x, and plus 7 both sides. You get 4x equal to 12. X is what? 3. Yes? So, what you're looking for then, change it back to that inequality sign. And don't reverse anything because we didn't multiply or divide by a negative number. All right, so it would be x is greater than equal to 3. For x, any number of, what does this mean? Oh. What does that mean? I know. In relationship to this. It means for any number, any real number, which is either greater or equal to 3, this inequality holds. All right? To test it, let's pick a number which is greater than equal to 5. Okay? If you pick 5, you put 5 here. 4 times 5, 20. Minus 7 is 13. 13 is greater than 5. Any number on the number line. 0, 1, 2, 3. For any number which is greater than equal to 3, all the way to infinity. This inequality holds. Let's look at example 3 on page 345. We have 1/3 a x, is less than 5. How would you solve that? Let's, again, assume for a moment this is an equal sign. So you have, and you can write this as what? 1/3 x is same as x over 3. Yes? Is equal to 5 over 1. Yes? Okay, now. X times 1 is equal to 15. Yes? Did I multiply or divide by any negative number? Did I do anything like that? No. So the equality sign doesn't change. So x, for any value of x, which is less than 15, that inequality holds. See, that's the meaning of this solution. It's telling you, pick any number less than 15, put it there for x, this holds. Take any number less than 15, and we pick number. Yeah, 1/3. For any x less than 15, no. Yeah, it does. Yeah, you're right. If you put any number x less than 15 on the number line, that inequality holds. Like, let's pick x as 12. Okay? If x is 12, we have 12 over 3, which is what? 4. 4 is less than 5. Take x 9. 9 divided by 3 is 3, less than 5. Right? Let's do B also. Minus 3x less than 21. Okay? Let's see. First I will come, and again, I will say, assume this is an equality. So I have minus 3x equal to 21. All right? Divide both sides by 3. You get minus x is equal to 7. Yes? But I don't want minus x, I want x. So I have to multiply both sides by minus 1. This becomes plus x, that becomes minus 7. Now, what should I do to the equality sign? I multiply both sides by a negative number. I have to reverse this. When you multiply or divide both sides by a negative number, you just have to remember, reverse the direction of the sign. So this should be x greater than minus 7, or any value of x greater than minus 7, that inequality holds. Give me a number greater than minus 7. Minus 7.
Minus 6.
Minus 6. Minus 6 times minus 3 is plus 15. It's less than 21. That inequality holds. So just remember, when you multiply both sides by a negative, the direction has to change. Next, look at example on page 46. Are you guys tired or are you guys okay?
Number 5.
Page 346, example 5. Says solve and graph the solution set. we have 2 times x minus 3 plus 5x less than or equal to 8 times x minus 1. All right? Again, for a moment, assume this is an equality sign. All right? So we have 2 times x minus 2 plus 5x equal to 8 times x minus 1. How do we solve it? Get rid of the parentheses. 2 times x, 2x minus 6 plus 5x. And here, 8 times x, 8x, 8 times minus 1 minus 8. Add the like terms, 2x plus 5x, 7x minus 6 equal to 8x minus 8. Yes? So add plus 6 to both sides, get to get 6 here, and subtract minus x from both sides. These two cancel, so 8 minus 8 plus 6 is what? Yep. These two cancel. We have 7x and minus 8x is what? Negative 1x. Now, I have negative x is equal to minus 2. I want the value of x. I have to multiply both sides by minus 1. Yes? So it becomes x equal to positive 2. But since I multiply, this direction has to be changed. So for all x greater than or equal to plus 2, that equal to plus 2. Let's start. Let's take 3. If x is 3. If x is 3, I have 3 minus 3, 0, so this part becomes 0. 5 times 3 is 15. I have 3 minus 1, 2 times 8, 16. 15 is less than 16. Solving a 3-part inequality, example 6, page 347. Because this is looking for value of x between greater than minus 3, less than or equal to positive 3. Let's look at this one. Minus 3 less than sign 2x plus 1 less than equal to positive 3. So to solve this, there are a number of ways to do it. Let's just go by the example in the textbook so I don't confuse you. First, we add I want to get rid of this plus 1 here, so there will be only x. This gives us, we're trying to find a range of values for x. If I add -1 to all 3 sides, again, I'm not multiplying, I'm not dividing. So I don't change the direction. -1, -3 is -4. These could cancel. I get 2x equal to 2. Okay? Follow me? Now I divide. I want to have x here, so I divide everything by 2. And please notice, I'm not dividing by a negative number. I'm not changing the direction of inequality. -4 divided by 2 is -2. 2 cancel. Less than equal 1. So here, this is your answer. For all values of x greater than -2, less than or equal to 1, this inequality holds. If you graph it, okay, I want to graph it would be all the values greater than -2, but not equal. So I leave it empty circle. Okay? Going all the way, but less than equal to a positive one. So here. So from here. That's in this range. For x, this inequality holds. All right. 347. Yeah, that's the other exercise, same thing. Again, let's go back to the PowerPoint for the online student. You're at a quadratic equation, multiplying two binomials using FOIL methods. Using FOIL methods. So we have A plus B, C plus E. Using the FOIL method is you do first the inner, this goes multiplied by that, and then this gets multiplied by this, the utter, and the inner is these two, B and C, and E and E. Now, I will explain what that means. All right, FOIL method. A binomial is simplified algebraic expression that contains two terms in which each exponent that appears on a variable is a whole number. Let's look at example 1 and 2 on page 351 and 352. Example 1 on page 351. We have x plus 3 times x plus 4. Okay, so first term is here. You have, say, a times here. So we have x times x, okay, which is x2. Yes? Then, outside terms, we have x times 4. Okay. Yes. Let's multiply one here. X times 4 is 4x. Yes? Then inside terms, we have 3 times x, 3x, and the last term, 12. So this is the answer. And 4x plus 3x becomes 7x, so the answer would be x2 plus 7x plus 12. Right? Now, let me even here show you something, because sometimes you have this equation and they ask you to turn it back in the original form. Right? Look at these two numbers. You are looking for two numbers that if you multiply, you get 12, add them, you get 7. And the sign should be plus. Okay? Two numbers. Add together, you get 7, multiply, you get 12. 4 and 3. So I want to reverse it. X plus 3 plus 3. Page example 2. Example 2 is the same thing, just like that. Basically, as you can see on your PowerPoint, the FOIL method, you have A gets multiplied first A by C, then A by D, then B times C, then B times D. FOIL. First, outer, then inner, and last. That's where we get the word FOIL. Okay. Factoring of a simple trinomial is a simplified algebraic expression that contains 3 terms in which all the variables have whole number exponent. Factoring is an algebraic expression containing the sum or difference of terms, means finding an equivalent expression that's a product. For example, factored form is like that. Now, I had to, there on the original PowerPoint, there was a mistake. I corrected it here. Please note, as you have x plus 3 times, in a parenthesis time x plus 4, a negative sign outside, when you multiply those things, x times x2, x times 4x, then that negative sign changes those things to minus. I made a mistake in the original PowerPoint that you have. I will change that in public. Okay, just wanted to mention that. All right. Now, when you trinomial form is that, you add the like terms, like just what we did here, and you get minus x2 minus 7x minus 12. The strategy for factoring x2 plus bx plus c, let's look at page 252. Look at that page 352, the box. We have x2 plus bx plus c. So when we have x2, we know we need 2 parentheses, we need x and x. Now, what you want is, you want 2 numbers that when you multiply, you get c. When you add them, you get b. That's basically is the whole idea. Example 3, at the bottom of that page. X2 plus 6x plus 8. Okay? You guys tell me how to do this. So you have x2, so x and x. I'm looking for two numbers that when you multiply, you get 8, when you add, you get 6. Yeah. What signs? Yeah. Let's look at examples. Let's go to page 354. Examples 5 and 6. Now, 6. All right. On page 354, example 5, it gives us 3x to the power of 2 minus 2x plus 28. Okay. X to minus 20x plus 28. So we need, again, parentheses. I need x and x. What else do I need for x? Well, yeah, this is x times x squared. What else do I need? One of them. Okay. Now, you are looking for two numbers. When you multiply them, you get 28. When you add them, you get minus 20. And then, I'm sorry? Okay. Then you have, it gives you over there in the table, it has given you different possibilities. Minus 1, minus 28, minus 28, minus 1. You basically remember prime numbers. Here they come in. 28 and minus 20 are the set on the step 2. It gives you the set of factorization for these two numbers. Minus 1, 28, minus 2, 14, minus 4, and 7. Of all the options are only minus 14 and minus 2. Because when you, these are very, when you multiply them, you get plus 28, and when you add them, you get minus 20x. This is a remarkable alternative. Minus 14 and minus 2. When you add these to minus 14, 14x, and 3x minus 2 minus 6x, you get minus 20. You follow me?
So you get minus, so is that?
What I'm saying, the only choices in all these different, you have to figure out what are the choices for getting 28 and 20. So all these different choices, 1 times 28, 28 times 1, 2 times 14, 14 times 2, 4 times 7, 7 times 4. The only one that meets that requirement, that if you put it, when you multiply it, you get you get plus 28, or minus 14, and minus 2. And when you add them together, not these two, when you add minus 14x and this 3 times, the FOIL method, minus 6, you get 20. So remember the FOIL method? A goes by that, and also by that.
So what you're saying is if you don't say it right away, just use it.
Yeah, you've got to write down a bunch of choices. If the coefficient of x was 1, we make it much easier. You can usually figure out what are the two numbers. But if it's not, then you have to keep in mind this FOIL method. Actually, I mean, the FOIL method, even the coefficient is 1, you use that. But when the coefficient is 1, lots of time you can just guess it in your mind. Clear? All right. Okay. Let's look at example number 6. We have 8y2 minus 10y minus 3. 8y2 minus 10y minus 3. So again, I need 2 parentheses. I need y and y to become y2. And I need, what else should I do? I need 8 and 1, but I can also write it as 4y and 2y. Yes? You have that option also. Then you have, this is more involved than the first one. You've got to figure out all the pairs of factors of the constant minus 2. You look at what are the factors of 3. It's either 1 time minus 3 or minus 1 times 3. Okay. Then you have to find the various combination of these factors that will give you this expression. And in that table, on page 355, you have all these different things, all these different factors. And the only one that holds is 4y plus 1 times 4y plus 1 times 2y, 4y plus 1 times 2y minus. Because first, this are one of these factors, okay? And also, when you multiply them, you have 4y times 2y, 8y, 8y squared, 4y times minus 3, 12y, then you have plus 2y and minus 6. No, minus 3. Which minus 12y plus 2y gives you minus 10. So you get that original 4. Yes? All I'm using is this FOIL method. this is AC plus AD plus EC plus ED. So you got to look at this and that and find the factorization for it.
So that's why we did one wise that it's on parentheses.
Yeah, because minus 3 is either 1 time minus 3 or minus 1 times 3. Of all the choices, you have to try all those choices. The only one that holds, that satisfies all of them, is +1 and -3. Clear? Okay, Max? Good. Okay. Okay. A quadratic equation in X is an equation that can be written in the form of, as you see in the PowerPoint, ax to the power of 2 plus bx plus c. A, b, and c are real number, and a is not 0. To solve quadratic equation, either you can use the quadratic formula, which you can see that, x is equal to minus b plus and minus square root of b squared minus 4ac divided by 2a. Or we can look at these examples 8 and 9 on page 356. Let's look at, for example, example 8. Are you guys clear or not? Okay. That formula you have to memorize. But x2 minus 2x equals 35. I want to make it into a quadratic formula shape, which was, as you remember, ax2 plus bx plus c. Okay, so I want to get rid of 35. I add minus 35. These two cancel. So I get x2 minus 2x minus 35. Now, you just tell me 2 parentheses. Yes? Then, fortunately, the coefficient here is 1, so it's easy. X and x. Give me 2 numbers that you multiply them, you get 35. You add them, you get minus 2. You actually do both cases. Yeah, because the addition also is negative. So, good. 2. Actually, 1, no, both cannot be negative. 1. So one of them is negative, one of them is positive. Which one should be negative? The larger one. Because when you add them, you get minus 2. Okay, 35. What are the 2 numbers that you multiply, you get 35. Add them, which actually subtracting them, you get minus 2. We know they have to be negative. At least one of them has to be negative, not both of them. Why do we know both cannot be negative? Because if both are negative, this would be positive. So, and we know the larger one should be negative. 7 should be positive or negative? Negative. And what should be the other one? Now, when they say solve it, they want the value of x. So you have x minus 7 equal to 0. Remember, because you're in the multiplication form. And x plus 5 is equal to 0.
That either this parenthesis 0 makes both sides 0. Yes? So, if I want to find the value of x, I add plus 7 to both sides. This tells me it should be 7. I subtract minus 5 from both sides. And it should be minus 5. These are the two values. And you must have two values because you have the highest exponent is 2. If this was 3, you must have 3 values. Okay. For these two values, this equation holds.
But it matters where we put the
I'm saying again.
It matters where we put the negative 5.
Oh, yeah.
Because it has to, if it's got to be positive, it's going to put 2 in.
I mean, are you talking about here?
Yeah, well, no. Yeah, you have x equals 7 and x equals negative 5.
Yeah.
So that's the two numbers.
Yeah. If I put minus 5 here, minus 5 to the power of 2 is plus 25. Minus 5 times minus 2 is plus 10, which is equal to 35. And 35 is equal to 35. If I put 7, 7 times 7 to the power of 2 is 49. 7 times minus 2 is 14, which subtracted to get 35. What it tells you, what it matters in solving algebraic equation, there are for true value of x is the equation.
But you're not going to put them up there. 1, 7, 1, 5 here. Or 7.
Oh, I mean, well, no. You see what I mean is when they give you this equation, if they solve it, you say these are the solution for x. For these two values, that equation. Example 9 on page 557. It asks us, okay, this is coefficient 5x2 minus 33x plus 40 equal to 0. Solve for x, meaning find the value of x. And I can tell you from here, again, because this is exponent is 2, you need to have 2 values. You must come with 2 answers for 5. Again, you get 2 parentheses, 0, you get x and x. Now, what should I put for the coefficient? Here is 5, what should I have for coefficient? Five and 1, because 5 number, cannot have it, any other, only 2 numbers that multiply it. 5 is 5 and 9, 5 and 1. So 5x and 1. Okay. Now, here comes the tricky part. You want to have that. You want to have 40. Remember the FOIL method? Again, what you're looking for is when you multiply the outer and the inner, and do all that things, you want to get 40. Now, 40 is multiplication of 8 times 5, minus 8 minus 5, 10 for all kind of numbers, but when we, again, when you factor it, again, you have to use those different options that you have, because this is positive, so both sides, and one is negative, so both should be negative. So when we multiply, we get 40. And I want to have minus 8 and minus 5, because as you multiply, you get, if you multiply 5x, you get 6x, you get minus 25x, you get minus 8x, and you get plus 40, which when you five x, 25, 8x, and 40. Okay, so you get 5x2 minus 33x plus 4. Okay? See, you follow? Okay. I looked at here, I saw plus. I looked at here, I saw negative. So it has to be, it can be both positive. It has to be negative times negative. So put the negative sign here. Factorization of 14, 8, and 5, and minus 33. Considering this 5x here, you have to keep that in mind. When you then do the multiplication, you get 25x minus 8x, which add up to 33. Right? Now tell me, what are the solutions for x? From here. So we have 5x minus 8 is equal to 0. And we have x minus 5 is equal to 0. Yes? Yes, we change it to this form equal to 0. Either of these practices, if you are 0, the quality holds. So I say 5x minus 8 is equal to 0, or x minus 5 is equal to 0. Right, following me? Yeah. So if here, from here I get 5x minus 8 equal to 0, I add plus 8 to both sides. These we can cancel. 5x is equal to 8. X should be 8 over 5. That's one answer. That's one of the solutions. Okay. The other solution is here. X minus 5 is equal to 0. This one. Add plus 5 to both sides. So you get x is equal to plus 5. So these are your answers. X plus 5 and x2 equal to 8 over 5. Put them over there.
And then you have this quadratic equation, example 10 and 11 on page 358, 359.
If you look at your textbook, example 10, it's basically 2x2 plus 9x minus 5 equal to 0. 2x power of 2 minus 9x, well, I mean plus 9x minus 5 equal to 0. All right? Now, he says use the quadratic formula. Remember, the general format that you have is a x2 plus bx plus c is equal to 0. All right? Now, this, you got to memorize this. This is the quadratic formula. So a is 2. B is 9. What is C? Then you have that equation, minus b plus and minus square root of b squared for ac square minus 4ac divided by 2a. You just plug in these numbers. B should be 9 plus and minus b squared 81 minus 4 ac. AC is minus 10. 9 minus 4 becomes plus 40 divided by 2a. And then you have to solve that problem. Ends up to be answer is 11. Because this becomes under 21. Square root of under 21 is 11. You have 9 plus and minus 11 divided by 4. I mean, yeah. If you add them, you know, it's 9 plus 11 is 20 divided by 4. 9 minus 11 is minus 2 divided by 4. This is 5, and this is 1 minus 7. These are the true answers. Follow me?
Yeah, just a lot of stuff.
Sorry.
A little bit.
Yeah.
This way down.
Let's go. Okay, are you guys okay? Do you need a break or no? Okay. All right. Graphing functions. You know what we call is Cartesian rectangular coordinate system is named after French mathematician René Descartes, consists of 2 perpendicular number lines, horizontal x line, vertical y x-axis, the vertical y-axis. The point of our intersection is origin, and then you have these quadrants. They're basically, as you can see in your PowerPoint, you have the vertical y-axis, horizontal x-axis, quadrant 1, x and y are positive, quadrant 2, y is positive, x is negative, quadrant 3, both negative, quadrant 4, x is positive, y negative. We plot points, you know, if we have point, as you can see, 0.35 means a point that its x value is plus 3 and its y value is plus y. So you go to the right 3 and you go up 5, intersection, you find that point. 0 minus 5 means its x value is 0, its y value is minus 5. So you go down on the y-axis 5 points. All right? When we want to plot points. A relationship between two quantities can sometimes be expressed as an equation of two variables, where y is a function of x, or we write y equal f parenthesis x, meaning when we say y is a function of x, when x changes, y changes. Y is dependent on x. Y is a variable. X is a variable, and y is a function. Let's look at example 4 on page 374.
These are simple things. Let me just. For example, f function of 4 for fx is equal to 2x plus 3. So you have x plus 3. That means x, the value of x is 4. Yes? Okay, so I just plug in 4 in this formula. So x is 4, 4 times 2, 8 plus 3, 11. So I'm looking at the point. Point has x and y value. Point of x is 4, y is 11. If I draw that Cartesian system, this is x-axis, this is y-axis, I want these are plus 4, 1, 2, 3, 4, plus 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the intersection of them, this is the point, plus 4 and plus 11.
Okay, so x is 4. Where did the 8 come from? Is it 4 times 2?
Which,
8.
where, okay, if you put 4 here, because this is x,
Oh, yeah.
they give us this function. So you have 2 times 4, you get it.
I got you.
Okay?
The graph equation in two variables is a set of all points whose coordinates satisfy that equation. One method for graphing such equation is point plotting method. Let's look at example 3, page 370.
Okay. Well, this one, we have to look at the textbooks. But I don't want to write all those choices. It says the total beverage costs $2.50. Okay. Okay. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass of $21. with the discount pass, the toll is reduced. With the discount pass, the toll is reduced to $1. Okay. The monthly cost Y of using the bridge X times can be described by the following formula. The monthly cost Y is equal to 2.5 times X, the number of times you use the toll, you use the bridge per month. Yes? Yeah. With the discount pass, Y is 21 plus 1x. I mean, you pay the $21, then the toll would be $1 each time you use the bridge. Okay? Following me? So you got two formulas. That's how we can solve it. Basically, you're trying to solve this equation, finding what's the value of Y. So what you do basically, as you can see on the page 373, you have two plots. You draw two lines, one for this one for this one. So you get for X, Y, first one, and X, Y, second. So you give different values, 1, 2, 3, 4, 5, whatever, and you find a value for Y. You have them over there on a table. Table 373 at the top of the page, page 373. You know, it gives different value for X, the number of time you use the bridge, and it figures how much you have to pay for using a monthly cost that you're paying. Are you following me? So you just plug in the numbers and you get all the different numbers. Then he has plotted those two lines in figure 7.5. And if you notice, they intersect at the point when point 14 and 35. Those two lines intersect. What does that mean? It means that if the bridge is used 14 times a month, the total monthly cost without the discount pass is the same as total monthly cost with the discount pass. If you use it more than that, if you use up to 14, really doesn't matter. If you use more than 14, then that pass will start working. Because if you can see on the plot, you can see on the figure, you can see that the line, the slope is lower, the cost becomes lower. Yeah, so exactly. But if you, let's say if a person every working day of the week 5 times a week, 35 times a month, no, 20 times a month uses the bridge, then start you saving money. But up to 14 is the same.
Graphing function. Let me see. Let's look at example 6 of page 376. And please take a look at your own textbook. You know, on example number 6 that you have in your textbook, it gives you two functions, fx and gx. Fx is equal to 2x. Gx is 2x plus 4. When you plug in numbers in both of them, you put number for x, you get the value for f, you get plug numbers for x, you get value for g. You find these two lines, you see they are parallel. But if you noticed, the line gx is moved 4 units toward right. And that makes sense because the function is 2x plus 4. The function is actually the first function plus 4. You see that? Example, let's see, example 6. Let's go to, again, page 38, it tells you to solve this and solve this problem. Again, you have to put in the value for x and find the value for the function. All right, any question? Linear function and their graphs. All equations of the form ax plus by equal to c are straight lines because the exponents are 1. When graph, as long as a and b are not both 0, such equation is called linear equation in 2 variables. The x-coordinate of points where the graph intersects, or the x-axis, is called the x-intercept. Where the line crosses the y-axis is called y-intercepts. To locate x-intercept, give the 0 value to y, solve for x. To find the x-intercept, a y-intercept, give 0 value to x and solve it for y. Now, a very important term is the slope. Slope, or, just the term slope we use in English. When there's a inclination in the road or a line, the slope of the line through 2 distinct points, x1, y1, and x2, y2, is the change in the y over the change in the x. In other words, it's y2 minus y1 over x2 over minus x1. And the formula is y minus the intercept is equal to 0b. If you look at your PowerPoint, slope-intercept form of the equation of a line, like if you can see here, rise over run, the change in the value of y over the change in value of x. You take y2 minus y1 over x2 minus x1. Y is equal mx plus b. M is the slope. Following me? When a slope is positive, the line goes up. When the slope is negative, the line goes down. If you want to graph it, plot the point contains the y-intercept, then obtain a second point using the slope. Use a straight edge to draw a line through the 2 points. Let's look at page 388. We have linear function called fx equal 2x plus 5y, actually, 2x plus 5y
equals 0. All right. We want to graph this equation. In order to graph it, we want to make it into the shape of, remember, y is equal mx plus b. We want to get it to this shape. Y equal mx plus b. M is this one. So I want to solve this for y. I want to have y on one side and everything else on the other side. I add minus 2x. These two cancel. So I get 5x is equal to, I get 5y equal to minus 2x. I divide both sides by 5. Y is equal minus 2 over 5x. And what's my b? 0. So, what's my slope? This is the m is the slope. Minus 2, 5. Before even graphing it, can you tell me, is this line going up or down? Slope is negative.
They're negative, so it's down.
So the change in y over the change in x. So rise over run. So all you have to do is find the y-intercept. If you find y-intercept, meaning you want a point that y is equal to 0. It makes y is equal to, if y is equal to 0, x should be minus 2/5 over x. So x should be, I'm going to point that y becomes 0. So if you draw the Cartesian line, first of all, I have the slope is minus 2 over 5. Minus 2 means I go this way, the change in y over the change in x, okay? Rise over run, but it's negative, so I go 2 points down. The other one is the change over the run is 5. Positive, 1, 2, 3, 4, 5. So I come here, this is my point. And the y-intercept would be when x is 0, so the 2 point, I draw the line. You guys follow? No. Y-intercept is where the x is 0. So if I put x 0, y is 0, so I get this is the y-intercept, this is the slope. Which, I'm sorry, should go this way. All right. Solving linear equation by graphing. A solution to a system of linear equation can be found by graphing both of the equation in the same rectangular coordinate system. For a system with one solution, the coordinate of points of intersection of the line is the system solution. Let's look at example 2, page 395. Again, to save time, just please look at your textbook. Example 2, page 395. It gives us two equations, x plus 2y is equal to 2, x minus 2y is equal to 6. Well, actually, plus 2y equals to 2x minus 2y is equal to 6. So you have to find y-intercept and x-intercept for each other. This one, the y-intercept, what's the y-intercept? X is 0. So if I put 0 plus 2y equal to 2, y is equal 1. Yes? So I have 0, 1. The x-intercept is y is 0. Yes? But x plus 0 equal to 2. X is 2. So 2, 0. Okay? I got 2 points for the first line. I've got x0, and this is my first point. The second point I have x2 and y0. This is my second. So I got 2 points. I draw a line. Okay? The other one. This one. Again, if I want to find the x-intercept, x should be 0 minus 2y equal to 6. Therefore, y is what? Not only y. Minus 3. Yes? So I have 0 minus 3. If I want to find the y-intercept, x minus 0 equal to 6. X is 6. So I get 6. I get 6 as all right. So I come here, 0 minus 3. X is 0, y is minus 3. 4 and 2, 3. So that's my first point. Y is 0, x is 6. 1, 2, 3, 4, 5, 6. So it goes like that. Where they cross is a solution, which would be 4 and minus 1. 1, 2, I'm sorry, should be, it would be 4 and minus 1. That's the solution for this equation, this system of equations. For x equal to 4 and y equal to minus 1, both these equations will be.
Okay. All right. If necessary, rewrite both equations in the form of ax plus by equal to c. Necessary, multiply each side by appropriate non-zero numbers. So the sum of the coefficient or the sum of the y coefficient is 0, x coefficient. Add the equation in step 2. Solve the equation. Back substitute to check. Okay. Examples 5 and 6, page 399. It gives you, this is very simple.
You want to solve this system we don't want to graph 3x plus 2y equal to 14. 9x minus 8y is equal to minus 24. So, in order to solve that, I want to add them together. So I want to cancel the x. So I multiply the first one, both sides, by what number? Minus 3. Because I want to become minus 9x so that I can cancel it with that. Okay? If I multiply it, it becomes 9x minus 6y minus 144. Then these two cancel. You get minus 14y equal to minus 168. Then you solve it for y and minus 12. Okay? Then you plug this into either of them. Doesn't matter. And find the value for this. Alright? So we plug in the second one, you have 9x minus 8 times 12 equal to 24. You just solve the problem, x would be equal to. Right?
Okay. We are almost done, guys. But
What page was that?
that on 399. Graphing linear inequalities in two variables. Again, replace the inequality symbols with equal signs, graph the corresponding linear equation, draw the solid line if the original inequality contains the equal signs, dash line if it's less than or greater. Choose a test point, usually the intersection point, and substitute the coordinate to test the validity of your answer. Then if the true statement result, shade the half plane containing this test point. Let's look at example for one of them on page 49. You see, if you look at example on page 409, example 1, it has 3x minus 5y minus 5y greater than or equal to 15. Okay? So it says replace the inequality with equal sign. 3x minus 5y equal to 15. Then, again, you solve this, you find the x-intercept, you find the x-y-intercept, you find the numbers 5 and minus 3. Okay? Then 5 and minus 3, so you can have a you have 1, 2, 3, 4, 5, 1, 2, 3 minus. So you have these two connected. All right? And because it has an equal sign, it makes a solid line. So it says for values greater or equal. So I'm going this side. I'm thinking about everything on this side. You guys follow me? Okay. Now,
No, that's it, actually. That's actually. This is, and you can choose a test point. You pick any number on this side, plug it there. If you put, if y is, let's say, -4. If I put -4 here, 3x -4 would be 20, greater than equal to 15. And if x be 0, and this would be 0, so 20 is greater than 15. If I pick any number on this side, let's say if I pick x -1, y 0, so I get -3, 0 greater than equal to 15. No, this is false because -3 is not greater than equal to 15 because I picked on the wrong side.
All right. If you have exponential function, y is equal to b to power of x, b is a positive constant other than 1, and x is any real number. Let's look at page 423. When you have exponential lines, you will have curvature, as you can see on the figure in example 1.
In example 1, so you have fx is equal to 2 to the power of x. And here you come also to the definition of log. I took a video, added a video today on lesson 5 regarding logarithm. Basically, logarithm is a reverse of exponent. So if fx is equal to 2 to the power of x, so this is your y, this is your function. So you plot x, y, 0, 1, 2, 3, 4, whatever, is a bunch of numbers, and you find values. 0 is 1, 2, 4, 8, and continues. And then you plot them, you get that line. You can see on figures 7.4.
Modeling with logarithmic function, please watch that video. That will help you explain what does it mean, logarithm. Basically, if fx is equal, if logarithm is a function, fx is log base b of x, but it's a reverse of an exponential form for x greater than 0 and b greater than 0. When we write y is a log base b of x, is the same as in an exponential form, b to power of y would be equal to x. These two equations, y log b of x and b to power of y equal to x, are different ways of expressing the same things. The first one is a logarithmic form, the other one is an exponential form. Graphic logarithm form, example 4, page 4 to 7. If you go to page 4 to 7 of your textbook, it says graph y log 2 of x. So then you give different value to x, you find its log, because y log 2 of x means 2 to power of y is equal to x. So if I give different values to y, like if y is -2, then x would be 1/4. You following me? And you just give -1, 0, 1, because, as again, remember, y log
2 of x is the same as you take this 2 to the power of y is equal to x. This is the exponential form, this is the logarithmic. So when you tell you draw this one, y like 2 of x, change it to exponential form, then give different value to y, find x, and then connect the dots. All right? But please watch that video.
Okay. Parabola again. Let's see. Oops. Okay. Graphing quadratic function graph y equal ax2 plus bx plus c, or f is a function of ax2 plus bx plus c called a parabola, can be graphed using the following steps. Again, determine whether the parabola is open onward or downward. If a is greater than 0, if the coefficient of x2 is greater than 0, it's toward up. If it's less than 0, it's toward down. Okay? Determine whether the vertex of parabola, the x-coordinate is minus b over 2a. The y-coordinate is found by substituting the x-coordinate into the parabola equation and evaluate. Find x-intercept, then find the y-intercept by replacing x equal to 0, plot, connect the dots. Example 6, page 430. So you have
Y is equal to x power 2 minus 2x minus 3. First, find out whether the parabola is open. How the parabola is open. Okay, what is A here? A is 1. A is the coefficient of B. Okay, so it's a open upward, greater than that. B is minus 2. And C is minus 3. All right? X coordinate of vertex is minus B over 2A. So basically, minus B would be plus 2, 2A would be 2, so it's 1. All right? The x coordinate of vertex is 1. We substitute 1 for x in the equation. We get the y coordinate. Put 1 there, y would be equal to minus 3. So the vertex is 1 and minus 4. Okay? Now, find the x-intercept. X-intercept, very simple, is where x is 0. If x is 0, this is y is minus 3. Okay? Find the y-intercept. If y is 0, okay, here comes the trick part. If y is 0, if y is 0, then you have one of those quadratic formulas. You have x2 minus 2x minus 3 equal to 0. So we have two parentheses, x and x. I want two numbers multiplied together, give me minus 3. Two numbers. Add, multiply them gives you -3, add them gives you -2. First of all, tell me about the signs. It has to be negative. Yeah. One has to plus, one has to be negative. The greater one must be negative because when you add them, you end up with -2. 3 is a factor of what? 3 and 1. So greater than, the larger one is -3, smaller one is +1. So the y-intercepts would be, got that, we got the x-intercept. The y-intercept has two values. It can be -1 and +3. See, either of these equal to 0. So x is -1 or x can be +3. All right, I know you get hurt like this. Okay. So, but here it is. If you draw the coordinate system, the vortex, which is pointed upward, we find the vortex is +1, -4. +1, 1, 2, 3. This is the vortex. So you know it's going that. So now we have the x-intercept. X-intercept is -3. Y is -3. If x is 0, y is -3. So 1, 2, 3. It has to go to this point. The y-intercept, when y is 0, I got two points, -1 and +3. Are you guys following? So I connect these. Sorry for my line. This is the
Okay. That's it. You're done. Sorry, guys. I will put the grades for your midterm last week tonight, and quiz 3 will be available in about 20 minutes. Any question? Is okay?
Is there an absence?
You can have. I mean, you're excused for the first one because you. Yeah. Friday. So you may not come next week.
It's a maybe.
Okay. Yeah, it's excused because that's a valid situation. Yeah, don't worry. Okay, guys.
Just making sure.
So we have a couple assignments and then the paper and then.
On the last session, remember you have your fine. Oh yeah. This you just.
Two assignments.
Yeah. Yeah.
Thank you, guys.
Good night.
Good night.
So stop. Let me stop the recording.